In this video, I will talk about energy, potential energy, kinetic energy, heat, and work. Energy is the ability to do work. For example, a battery, which stores chemical energy, can do electric work. Gasoline, which also stores chemical energy, can combust in oxygen and provide thermal energy to do work to the piston. If you press the control button and click the mouse, you will go to this YouTube video. This engine converts the chemical energy in gasoline to the mechanical energy of the piston. Now slow motion. The combustion releases the chemical energy of the gasoline. It heats up the gas inside the chamber. The gas expands and pushes the piston downward. So it's a good example of the transformation of energy. Now what's the unit of energy? The SI unit of energy is 1 joule. 1 joule is equal to 1 kilogram times meter squared divided by second squared. Kilogram is the fundamental SI unit of mass. Meter is the fundamental SI unit of length. Second is the fundamental SI unit of time. 1 joule is also equal to 1 Newton times meter. 1 Newton is equal to 1 kilogram times meter divided by second squared. There are also non-SI units. 1 small calorie is equal to 4.184 joules. 1 food calorie with an uppercase C is equal to 1,000 small calories, or 4,184 joules. Energy takes two different forms, potential energy and kinetic energy, PE and KE. PE depends on the relative positions of the objects. Potential energy can be gravitational or electrostatic. Two separate masses have gravitational potential energy. Two separate charges have electrostatic potential energy. For example, in the hydrogen atom, between the nucleus and the electron, there is electrostatic potential energy. In particular, its attraction. Kinetic energy depends on the relative speed of the object. So if you are driving a fairly small car, let's say it weighs 1,000 kilograms or 2,200 pounds, and it moves at 10 meters per second, we can compute its kinetic energy. The formula is 1/2 times the mass times speed squared. In this case, it's 1/2 times 1,000 in the SI unit times 10 meters per second squared. The result is 50,000 kilogram meter squared per second squared, or 50,000 joules. Or sometimes we write 50 kilojoules for simplicity. But wait, doesn't this car also orbit about the sun at 30,000 meters per second? It's true. The Earth orbits about the sun at 30,000 meters per second. Therefore, the car is also orbiting about the sun. However, in science, we usually use the non-moving ground of the Earth as the zero reference. Therefore, we can do this simpler calculation to get the kinetic energy of the car relative to Earth. We mentioned that energy can be potential or kinetic. What about chemical energy? Is chemical energy the third form of energy? No, it's not true. Chemical energy is simply one form of potential energy because it depends on the relative positions of atoms. Now, what about photon energy? Well, it's simply kinetic energy if the photon is traveling in vacuum. What if the photon or the light is traveling in a medium such as air or water, and then the electromagnetic field of the photon will be interacting with the medium, and then the photon energy is the sum of kinetic energy and potential energy. Energy can be transferred from one object to another via two different processes, heat and work. For example, if we mix hot water with cold water, heat flows from hot water to cold water. Energy is transferred from hot water to cold water. If you are pushing a shopping cart in a supermarket, you are doing work to the shopping cart. Energy is transferred from you to the shopping cart. What if you are sitting in a moving car? Then the car is doing work to you. Energy is transferred from the car to you.